Okay, so chapter 8, we start off really simply. You have to excuse my penmanship, and if it's me handwriting something, you probably need to ask for clarification whether or not we're talking about this equation or this question in your solving, or one of the other questions that we'll look at in just a minute. This question is saying, what are the solutions for the sine theta is equal to 0.5? This is a no calculator question. I threw the graph up here just so you can see where these solutions take place. So if you're looking at this problem, theta, if you want to continue with the idea of, oh, I want to show by using my calculator maybe, which we don't want you to do, that's what we're trying to figure out. Sine inverse of 0.5 is equal to theta. What theta value has a sine that's equal to a half? 30 degrees. So if we're going to be in degrees, then you would say theta is 30 degrees. But, well, for 360n. So theta would be 30 degrees plus 360n, because it says what are the solutions, and there's lots of solutions. There's an infinite number of solutions. But
the 30 is a reference angle.
Correct.
So the 30 in the other quadrant.
Which is?
Like 50.
Yeah.
20 is 10. No,
No.
20 is 10. 200 is 10.
No. I'm not arguing that 180 plus 30 is 210. I'm just saying no, it's not an answer.
Oh, just those two.
Just those two, because?
9.
Correct. We whip a little all students take calculus on it. We got to be in quadrants 1 or 2 because the sign is positive only in 1 and 2. So theta is 30 plus 360n, and theta is also 150 plus 360n. Okay? And you look at this picture. Here's where the green line is where it's a half. Where does that occur? It occurs at 30 degrees. It occurs at 150. We come around again, it occurs at 390, and it occurs at 510, somewhere over here. You could also go backwards and find them going backwards. Why do we need to have the 360n in this problem?
It will always be 0.5 any multiple of that.
Okay. What about the question tells you that you need the 360n? Okay. The sign is little s. Little s sign means all values, any angle. If it was capital, then you have a restriction. Okay? It's capital. Okay? Now the two solutions that we care about in particular are the 30 and the 150. All the other solutions are adding the 360n to the 30 and to the 150. That's what we mean by these two particular solutions. Y equals little sine theta. A lot of times what they will do is they will restrict your domain of theta to be in the first spin, the first revolution. Normally they'll say, go ahead and include the 0, but don't include the 360. In interval notation, it'll look like this. 0, HUD on the 0, shun on the 360. So if we look at y equals sine theta, this is from 0, we can include the 0, to the 360 where we don't include the 360. Or the 2 pi, whether you're in degrees or radians. Just look at the restriction. Everybody good there? These are the angles you need to be very familiar with. In my opinion, I think that if you know what's going on in quadrant 1, along with your quadrantal angles, you're really all set. And again, what happened in the last chapter, people didn't know the trig values for those quadrantal angles or the 30, 45, and 60, so they were faking it. And when you fake it, it doesn't really work very well. So you need to learn these 30, 45, and 60. You've got to make sure you learn those. And I'll show you another slide here in a minute that might help you with that. In radians, you need to stop converting. Half of you are still converting. You get pi over 6, and you say, oh, pi over 6 radians. I don't want to work in radians. So you multiply by 180 over pi, and that's how you get your 30. And then you do everything in degrees. You need to stop. You've got to learn how it works in radians. You need to memorize it. And again, if you know these three, this is pi minus pi over 6, 5 pi over 6, 3 pi over 4, 2 pi over 3. So it's not really that hard to figure out if you know those ones in quadrant 1. But you got to know them. And if you know who you are, you know, hey, I faked it. What are you going to do about it? This one, I was going to shrink it down a little bit so it would fit so you could see it, but I think it's better that you print it if you want it printed. This slide right here is fantastic in that it tells you really everything that you were supposed to know from that last chapter, chapter 7. This is the unit circle. How do you know it's the unit circle?
The points on the axis are ones and zeros.
You're right. So from the origin to the points on the axis, we have 1, 0. That means the radius is 1 all the way through here. So if that's true, what does the 1 represent? Cosine, and the 0 represents sine. Now, if you think about how this works, every x and y on the unit circle represent cosine comma sine. So at 30 degrees, the coordinates of this point where the angle 30 degrees intersects the circle would be root 3 over 2 comma 1/2. Cosine of 30, root 3 over 2. Sine of 30, 1/2. Both of my kids had to learn this stuff. My oldest son was the least likely person to study, but he learned this stuff very rapidly. If you look at these, in quadrant 1, these are, in fact, everywhere, they're all over 2. Everything's over 2. And in fact, this is really could be written 2 over 2. But you don't really need to worry about that. This could be 0 over 2. So over 2, you have 0, 1, 2, 3. If you're looking at the number parts, you just have to know that these two are the radicals. Coming back the other way, it's 0, 1, 2, 3. And again, radicals for the 2 and the 3. Root 3 over 2, 1/2. Root 2 over 2, root 2 over 2, 1/2, root 3 over 2. Again, these two flip to become these. These are identical. There's only 3 values you have to know in there. Memorize them, learn them, internalize them. You need to know that this is 30 and it's pi over 6. 45 pi over 4. 60 pi over 3. ASTC. Everybody's positive here. The big 3 and the little 3. For the big 3 in sine, or in quadrant 2, only the sine is positive, which means the reciprocal cosecant is positive. Everyone else is negative. How do you find your angles here? 180 minus alpha or pi minus alpha. This is your reference alpha in quadrant 1. Only the tangent and the cotangent are positive in quadrant 3, and only the cosine and the secant are positive in quadrant 4. This is 360 or 2 pi minus alpha. This is 180 plus alpha, or pi plus alpha. and then your quadrantal angles are all there. This stuff needs to be, everything here you should have memorized. And again, do I need you to memorize these values or be able to get them quickly because you know these values? That's what I do. And you should be able to do it in a matter of a second or two. If you continue to fake it, it's going to continue to get worse. Any questions about that? Is everybody good? Anything you're not clear on? You can print this, it's online. But you got to memorize it. So find the values of x where x is between 0 and 2 pi, such that sine x is 0.6. What is this telling you here in this equation? Sine x is 0.6. What does that mean for us? Yeah, but what does it mean? Yeah, before that, use a calculator. Okay, everything that was said was correct. X is going to equal sine inverse of 0.6. But we're going to use a calculator for this. Okay? Your calculator is going to give you capital S sine. So when you do sine inverse of 0.6, you're using domain restriction 1 and 4. Which quadrant are you going to get your answer in? 1. Half of you are going to get your answer wrong right now. What's the answer? Somebody's got to have the right answer.
36.
That would be wrong.
0.644.
X equals
0.644.
Why are you making that face? She wants to know how you got that. What did you do first? Switch to radians. How do you know that we need to switch to radians? Because the domain restriction is in radians. So you need to be in radians. Okay? So I'm just throwing that at you without giving you the reminder. It's the first thing you got to be conscious of. Am I in degrees or radians when you're doing an inverse? Now what?
Plus 2 pi n.
We've got a domain restriction. So you don't need to go 2 pi n because that's the only one in quadrant 1 in the first revolution.
Let's do that plus 4 This is going to be the second quadrant.
It is. And how do you find your angles in quadrant 2?
Plus
Oh.
minus that.
I like to draw it because I'm visual. This is where pi is. I just didn't hear it. X from pi. Pi minus 0.644. So x equals 0.644 radian. What else? 2 point. No, we could do it telepathically, or I could do it for you.
2.49. How does one do this?
2.4.
What's the calculus?
Really? Thank you. So these are the two values for x in this domain restriction.
When you have a radian value that doesn't have pi in it, how do you convert that to degrees?
Multiply by 180 over pi.
But then there's no pi in the original. So
So,
there'd be a pi.
so 180 times that value. So like for example, 180 times 0.644 divided by pi, use the pi button. Sure. Pi's a number, even though it's nice when it cancels and you have your regular, your pi over 2, pi over 3, pi over 4, pi over 6, that kind of stuff. That's great that it cancels, but life doesn't always come out pretty. Taylor, just take your other part. Taylor, come in and switch versions of our test. No? Okay. Everybody good on this? Notice the difference between this question and the question we just did. What's the difference? And what is that? No domain restriction. Well said. No domain restriction means that our answer for x is going to be what? .498 plus 2 pi n.
Can you go over something?
Sure.
Why isn't that sign capitalized?
Why what?
Why isn't the sign there capitalized?
Because I'm telling you it's lowercase sign, which means it goes forever, but then I'm using a domain restriction, which takes you out of capital S sign. If this was capital S, you would have had how many answers? Just one, because that tells you that you have to be in 1 or 4, and we're going to get the 1 by doing sign inverse. Because I'm saying domain restriction on lowercase sign, that means I'm going to go all the way around, which means from here, and then we do all students take calculus. That was a great question. My fault for not addressing that right away. Okay. Why is it that this doesn't get us just here? Because it's little sign with a domain restriction. Okay. Everybody good with that? Okay. Try this one. Try this one. It's in degrees. How do you know? Actually, this is a big giveaway too. What do you do first?
Stuff on that one.
What's that? Add 1.
Add 1 to both sides.
Thank you. And then what? You can use a calculator on that part. So theta is going to equal sine inverse of 3 over 4. What do you get for theta when you use your calculator for this? Good question. What is it?
48.5.
48.590 degrees. Anyone not able to get that first value? What do we do with that? And get the other one in quadrant 2 by doing 180 minus 48.950. So the other value for theta is 131.410. Those are the two angles in the first revolution that will make this equation true. They're the only two angles that will make that angle true, or that equation true in the first revolution. Any questions? Okay, try another easy one, and we'll do one that's more complicated. All right, so what are we doing first? Now at this point, the only time you should stop is when you're above 1 or less than -1. Be very careful. Once you get to cos or sine, your max and min values are 1 and -1. You have to be between 1 and -1 on the side. So we're good. theta equals cos inverse of negative 2/3. What did that tell you for theta? 130, that's what the calculator gives you? 131.810 degrees. Anyone not getting that? Okay? So if we look at the picture, here's your 131.810 degrees. What's your reference alpha for that? And what is the value? 40.
8.19.
And how do you get that?
You subtract that value from 180.
180 minus 131 gives you your reference alpha. If we whip let students take calculus on this, what quadrant is our other angle going to be in? Quadrant 3. Why quadrant 3? Because our cosine is negative. It needs to be in quadrant 3. How do we get to quadrant 3? Add. Not to 131. What do I add 48 to? 180. 180 plus your reference alpha gives you your 228.190 degrees. If I did it right. 228.190 degrees. Those are the two angles in the first revolution that have a value that will make that equation true. Everyone follow? Yep. Good question. Now this is a reference alpha, right? And I only found that so I could get here. The cosine is equal to negative 2/3. So when you do all students take calculus, you're going to know in advance, I got to be looking at quadrants 2 and 3. Because here and here, 1 and 4 quadrants, cosine is positive, right? The calculator gives you the quadrant 2 angle. Because capital C cosine only works in quadrants 1 and 2. Does that make sense to you? So then you use this angle to find the reference alpha, which allows you to get the other angle in quadrant 3. Even though we don't need reference alpha for our answers, we need it to find the answer. If that makes sense. Everybody good?
Wait,
And this is me, wait.
Wait.
why is it 48.190? That's the answer.
Okay, again, in quadrant 1, tell me about the cosine. It's positive. What is this cosine?
Oh, negative.
Negative. Before I even start looking at angles, I know that my answers have to be in quadrants 2 and 3.
Oh.
This is like deja vu, huh?
I know, but I was thinking, I don't know, I was thinking, I guess I was thinking of when you capital C is restricted to like the top 2.
It is.
Yeah.
Capital C cosine is restricted, so your calculator will only give you the quadrant 2 answer.
Yeah, so I was thinking like you had to have that.
Are you okay?
Yeah.
There was some babbling there.
Yeah. I
Okay.
get it.
So you're quadrant 2 and 3.
Yeah.
We need reference alpha to get to quadrant 3, but it's not part of our answer.
Yeah. Okay.
Okay? Try this one.
Whoa.
What should you do first? You have options, but what do you want to do? Someone needs to commit. Multiply by 3. So 5 cosecant x is equal to 27 over 4. Do what? Okay. What could we do? Divide by 5. Now, right from the beginning, what could we have done? So we only have to do one line. Multiply by the reciprocal, 3 over 5, and you go right to 27 over 20. You're welcome to do that, multiply by 4 and then divide by 5 if you really like to do a lot of Oh, it absolutely works. It's just mathematically, you're doubling your work, tripling it. It's not okay. You need to start looking at, I'm in honors pre-calc. Why don't you, let's add 4. Let's add 4 here. That works,
Can't find four. Oh yeah, there you go.
right? And then I'm going to go ahead and subtract 4 next. This is just for fun, right? We don't want to go there.
You get the right answer.
Again, I understand that it's correct, and I understand that was your first instinct. Because your first instinct leads you to correct answer doesn't mean there isn't better ways to do it. You need to start adopting better ways to do it. Just because something works, and it was the first thing you tried, that's why you got to look for better, faster, more efficient. So what do we do now?
I did sine inverse versus that.
Okay, so what do I need to write down next? In order so that I don't get points taken off because my work isn't good.
X equals
No?
uneven.
Sine of x
20 over.
is equal to 20 over 27.
Otherwise, that's cheap.
Well, again, I'm not suggesting you're cheating. I'm suggesting you're doing stuff in your head that you're not telling me about.
But there's a more efficient way to do it. That's
Right.
the voice of work.
So then x would equal sine inverse of 20 over 27. So again, you're utilizing your calculator. You should know where are your answers going to be before we even bother. Quadrants 1 and 2. We have a positive value for sine and a positive value for cosecant, so we should get 2 answers, one in quadrant 1, which should be the first answer out of your calculator. And what's that?
834.
0.834. Sorry. So 0.834 is your quadrant 1. How do you find quadrant 2? Pi minus 0.834. So your second value for x is going to be 2.30. If it's 0.7, we need to fix that, because if it's wrong at that decimal place, you will lose a point. Everybody needs to get the same. Is it 8 or 7?
It's 8.
So I have
It's 8. You round up. Let me repeat. It's 4.
yeah,
On the other side, it's pi minus the answer that you got.
on your calculator.
Okay.
You cannot round here and then come over here. Use the number on your calculator. And then you need to use your pi part, not the 0.14. Okay? So 3
It's definitely.
It's 7.
It's 7. It's 7 people. It's 7.